This is another series of FOA hands-on hints videos focusing on certain types of equipment and components we use in fiber optics. For this video, we're going to talk about doing visual inspection with a microscope. And we'd like to thank AFL Noise for loaning us the microscope and the Simple View software that we're going to use to show you how a microscope works. For this presentation, we borrowed a video microscope from AFL Noise. Video microscopes are nice because they allow you to see a large image on the screen of a PC or project it for a whole class. Optical microscopes work equally well, just not quite as convenient. What we see here is a typical end face of a connector that's quite dirty. The microscope allows us to look at the connector, see dirt, scratches, other defects, and also tell us when we need to clean a connector. So let's clean this one. AFL Noise also sent us several of the Fujikura one-click cleaners. These convenient dry cleaners have fixtures for holding the connector, and all you do is snap it once or twice to do a thorough dry cleaning of the end face of the connector. You can also use lint-free wipes and isopropyl alcohol or any of another types of dry cleaners, all of which are well tested and work quite well. The secret is just to make sure the connector is clean by re-inspecting it with a microscope. And that's what we see here. After cleaning the connector, you can see the end face is free of dirt and very, very well polished. That's a good connector. But what we can do is we can look at lots of different types of connectors, and we can learn a lot about how connectors get dirty or how to spot defects in the connectors. So let's look at some more connectors. This is the end face of a multi-mode SC connector, which we've cleaned fairly well. And now what we'd like to do is demonstrate what happens with certain types of dirt. So notice how nice and clean it is, and watch what we do next. All we did was take that nice, clean connector and touch it to our fingertip. Your skin, of course, is covered with oils, and those oils are, well, generally pretty dirty. They bead up on the end of the connector, as you can see here, and often you'll even see small specks of skin. The warning, of course, is don't touch the ends of those connectors. But if you do, be sure to clean them thoroughly afterwards. So we cleaned that exact same connector, and then we dropped it on a carpet. And look what it picks up just from being dropped on a carpet. This connector would not be a very good connector to pick up and patch to another cable, because all that dirt will cause loss or even cause scratches on the connector. So what you want to do is take this connector, very thoroughly clean it before you connect it to anything else. We often warn fiber optic users about mixing and matching fibers. You can't connect 50 micron fibers to 62.5s or either multi-mode type to single modes. But then the question comes up, how do I tell the difference? Well, the microscope can tell you. All you have to do is to put a little bit of visible light down the core of the fiber and look at it in a microscope. Single mode fiber is really easy to identify because the core is so small. But if you look at 62.5 and 50 micron fiber, you can actually see a subtle difference in the size of the core. And once you've looked at a lot of fibers, you'll be able to quickly identify one or the other. The microscope also allows us to determine how well connectors have been terminated. So what we have here are 3 separate patch cords, and all of them show problems. If you look at this one, you can see there are scratches on the ferrule. The fiber itself is polished fairly well, but the fiber is very much smaller than the hole in the ferrule by a good 10 microns, and it's offset all the way to one side of the hole. This is one of the reasons we always tell people when they're terminating connectors to rotate the connector as you insert the fiber through the adhesive, because it will float the fiber into the center of the hole, preventing problems like you see here. Here's another problem. If you look at this one, the dark ring around the fiber sort of looks like the same larger hole we saw in the previous connector. But if you look more closely, you'll see that's just a shadow. And this is a fiber that's actually protruding up from the surface of the ferrule in the connector. This protrusion makes it very difficult to match the fiber up to other connectors when you're mating it, and can also cause damage if it's dirty. This is just an improperly polished connector. This is the end face of a commercially made connector on a patch cord. And as you can see, the polishing polished only the fiber. The connector itself, the ferrule, does not appear to be polished, and there's a lot of hackling or breaking along the outside of the fiber. It looks like this fiber was not properly polished during the first stages. This is why we always suggest inspecting all patch cords. Commercially made patch cords may or may not be of the quality you expect. And of course, whenever you take a patch cord out of its packaging, it has a dust cap on the connector. And we always say inspect connectors and clean them after you take the dust cap off, because there's a reason they call it a dust cap. It's usually full of dust. This video hopefully has shown you some of the things you can learn from visual inspection of fiber optic connectors. You can learn how clean they are, how well made they are, and you can determine that connectors are properly cleaned before you patch them to another cable. We'd like to thank AFL Noise for the loan of the visual microscope that we used. And we'd like to suggest that if you're interested in more about visual inspection, testing, or fiber optics in general, that you view the other FOA YouTube videos or go to our online guide at our website.